All right, this is also our homework sheet from yesterday. This is our mixed naming worksheet, ionic, covalent, and acids. I've worked through the first 38 on a different video. Now we're going to flip the paper over, and we're going to look at, we're going to work through 51 through 75 in this video. All right, so this is a mixed bag. We're starting with an acid. So we know for 51 that acids begin with a hydrogen. So we're going to have a hydrogen. And then we have to look at, all right, the fact that we have hydroiodic acid. This prefix, hydro, tells me that what's going to come after the acid is going to simply be an element. So I'm going to look at the rest of the name, hydroiodic acid. What element does iodic come from? Comes from iodine. Hydrogen has a +1 charge. Iodine has a -1 charge. So the formula for hydrogen iodide, if I crisscross the ones, I will get HI. And that is the formula for hydroiodic acid. All right, let's look at hydrosulfuric acid. Again, we have a prefix hydro. Hydro tells me that what's going to come after the hydrogen is going to simply be an element. If I look at sulfuric acid, I can tell that the element that's going to come behind hydrogen is going to be sulfur. That doesn't mean that that formula is finished. I need to finish that formula by looking at charges. Hydrogen always has a +1 charge in an acid. Sulfur, if we look on the periodic table, it's in group 16. Elements that are in group 16 have a -2 charge. Just like we've done in class, in order to write the formula, we crisscross the numbers for the charges. So I'm going to need a subscript of 2 for my hydrogen. I'm going to need a subscript of 1, which is understood and not have to be written, for the sulfur. So hydrosulfuric acid is going to be H2S. If you're having trouble with acids, there's a great video that's posted in this Google Classroom assignment on naming acids, and I would suggest that you take a look at that video as well. And it'll walk you through naming and writing formulas for acids much more slowly and carefully. All right, let's look at calcium sulfide. All right, calcium is a +2. Sulfide is a -2. Those two charges already add up to 0, so that tells me I only need 1 calcium and 1 sulfur in my formula. Dinitrogen pentoxide. Now I'm seeing Greek prefixes. Greek prefixes tell me that I am going to have 2 nonmetals. Greek prefixes tell me how many of each nonmetal I'm going to have. Dinitrogen tells me I've got 2 nitrogens. Penta means 5, so pentoxide means I have 5 oxygens. Aluminum sulfate. Aluminum is the first part of this compound. Aluminum is one of our staircase of 6. So our 6 elements that we know charges for that are in the staircase. Remember, silver is +1, cadmium and zinc are +2, indium, gallium, and aluminum are +3. So aluminum is +3. Sulfate is a polyatomic ion. It's SO4, and the charge on sulfate is -2. We're going to crisscross those charges, so I need to take this 2, and it becomes the subscript for aluminum. I need to take the 3 of aluminum, and it's going to become the subscript for sulfate. So I'm going to have Al2, and then in order to indicate that I need 3 sulfates, I'm going to have to put sulfate in parentheses. So here's SO4, 3. All right, now we're at another acid. This time, this is the first acid that we've seen on this side where we do not have a prefix hydro. So it just is sulfurous acid with no hydro. That tells us, acid tells us we're going to have a hydrogen in front. The fact that the name does not begin with hydro tells us that what is going to come behind the hydrogen is going to be a polyatomic ion. Because the acid ends in OUS, that tells us that the polyatomic ion that is going to follow this hydrogen is going to end in ITE. So sulfur is the stem for sulfate, for sulfite, and for sulfur itself. But if we have OUS acid, we know that we're talking about the sulfite ion. So sulfite is SO3. Sulfite has a charge of -2. Hydrogen has a charge of +1. When we crisscross those charges, what we're going to end up with is 2 hydrogens and 1 sulfite. So H2SO3 is going to be our formula for sulfurous acid. For nitric acid, again, there's no hydro. We know it's going to start with H because it's an acid, so H. We know that it's going to have a polyatomic ion behind the H because we see no prefix hydro. So what polyatomic ion is going to give us nitric acid? Because the ending of the acid is ic acid, that tells us the polyatomic ion is an 8 polyatomic ion. So what polyatomic ion would have the base NITR? It's going to be nitrate. Nitrate is NO3 and has a -1 charge. So hydrogen has a +1, nitrate has a -1. Those charges add up already to 0, so I only need 1 hydrogen and 1 nitrate ion to write the formula for nitric acid. Dihydrogen monoxide, we see Greek prefixes, tells us it's going to be 2 nonmetals. Dihydrogen tells me I'm going to have 2 hydrogens. Monoxide, mono is the prefix for 1, tells me I'm going to have 1 1 oxygen. So we have H2O. So water has another more scientific sounding name, dihydrogen monoxide. Trisulfur monochloride, again, we see Greek prefixes, so it's going to be 2 nonmetals. I'm going to have 3 sulfurs and 1 chloride. Selenium monoxide, again, 2 nonmetals. Selenium Se. The fact that I don't have a mono just tells me that the first one only has 1. But I see mono for the second element, so I only have 1 oxygen. So I have 1 selenium, 1 oxygen in that compound. All right, here's a new one. I don't think we've practiced this one before. Hydrotelluric acid. Hydro, that prefix hydro, tells us we're going to have a hydrogen and an element that comes behind it, not a polyatomic ion. Telluric comes from the element tellurium, Te. Tellurium it's in column 16, just like sulfur and just like oxygen. So tellurium has a -2 charge. Hydrogen has a +1 charge. So when I crisscross the charges, I'm going to end up with H2Te as my formula for hydrotelluric acid. Tin 4 sulfite, metal polyatomic ion. Tin is SN. The Roman numeral 4 here tells us that our charge on the tin is +4. Sulfite is our second part. Sulfite is SO3 and has a charge of 2-. If I crisscross the charges, I'm going to get, or if I crisscross the numbers, I'm going to get 2 tins and 4 sulfites? Well, both the 2 subscript and the 4 subscript are divisible by 2, so I can simplify this into a simpler form. And so if I divide both of those subscripts by 2, I'm going to get SN1 SO3 2, which is the best formula that I want to, that's the formula I want to use. Carbonic acid. Carbonic acid, again, we're going to start with hydrogen in front. The fact that it does not have hydro as a prefix in front tells me it's going to be a polyatomic ion that follows. What polyatomic ion is going to have the stem carbon and is going to end in 8? So carbonic acid has to come from an ATE polyatomic ion. So the only polyatomic ion that has the stem carbon and that ends in 8 is carbonate. So carbonate is CO3. The charge on carbonate is 2-. Hydrogen is +1. I'm going to crisscross the numbers. I need 2 hydrogens and 1 carbonate to balance the charges. Barium acetate. Barium is Ba. It does not give us a Roman numeral because we are supposed to already know what the charge of barium is. We do because barium is in column 2. So barium is +2. Acetate is C2H3O2 and has a -1 charge. So when I crisscross those numbers, I need 2 acetates, 1 barium. So 1 barium, I don't have to write the 1, it's understood. But in order to show I need 2 acetates, I have to put acetate in parentheses and put the 2 behind it as a subscript. All right, now this one is interesting. Number 65 is a little bit, you probably would not have one. In fact, I know you won't have one exactly like this on the test tomorrow because there's 2 issues with this. Number 1, zinc does not need a Roman numeral, so that's a little bit redundant in this. So it's telling us that zinc is a +2, but we already know that. So zinc is a +2. And then we have not had to learn periodate. However, we did learn that iodate is IO3-. Periodate simply means add 1 more oxygen. And when we were talking about polyatomic ions, we had that discussion about how the name can change as we change the number of oxygens. So if we add 1 more oxygen to an ATE ion, we get per. So IO4- would be periodate. All right, so knowing that, if I were balancing the charges here, I'd crisscross. This is a -1. Crisscross the numbers. I need 1 zinc and 2 periodates to balance that charge. But again, periodate is not a polyatomic ion that you had to memorize, and so it is not one that I would put on the test. Chloric acid. Back to acids again. Looking at chloric acid, we know it's going to be a hydrogen. It's going to be a polyatomic ion that comes after the hydrogen because there is no prefix hydro on this name. So we know that because chloric ends in ic acid, ic acids come from ATE polyatomic ions. So chloric acid is going to come from an ATE polyatomic ion that has chlor as a stem. That's going to be chlorate. So chlorate is ClO3. Chlorate has a -1 charge. Hydrogen has a +1 charge. they already add up to 0, so chloric acid is going to be HClO3. Silicon pentanitride, we see Greek prefixes here, so we know that this is 2 nonmetals. We don't see mono in front of silicon, so we know that there's just one. We don't see any Greek prefix there, so it's understood that the first element would just have one atom. But pentanitride says that we need 5 nitrogens. Bromic acid is going to come from bromate. So just like chlorate, bromate is BrO3 with a minus. So we're going to have bromic acid is going to be a hydrogen with bromate. So hydrogen is +1, bromate is -1. Crisscross, they already add up to 0, so HBrO3. Pentaphosphorus heptaoxide is going to be 5 phosphorus, that's what penta means, and 7 oxygens. Sodium oxide. Sodium, we look on the periodic table, we know sodium has a charge of +1, oxygen has a charge of -2. Crisscross the numbers, and we're going to get Na2O as our final formula. Hydrofluoric acid. Now we've got a hydro. Hydro tells us, when we see it as a prefix, that we are going to have an element that follows. So hydrogen, what element is going to give us the prefix fluor? It's going to be fluorine. Hydrogen is +1, fluorine is -1, so that is okay as is. We're going to write that as HF. Calcium bromate. Calcium is Ca, has a 2+ charge. Bromate is BrO3, has a -1 charge. Crisscross, and we need 1 calcium and 2 bromates for that formula. Hydrobromic acid is going to be like hydrofluoric, only this time our element is going to be bromine. Hydrogen has a +1 charge, bromide has a -1 charge, so HBr is going to be our formula for hydrobromic acid. Silicon dioxide, SiO2. And then the last one, we're back to a metal with a Roman numeral. So nickel is Ni. The Roman numeral 3 tells us about the metal. Nickel has a +3 charge. Sulfide is an element, not a polyatomic ion. It comes from the element sulfur, not a polyatomic ion, because of that ending IDE. So nickel, sulfide, sulfide has a -2 charge. Crisscross the numbers, and you're going to have nickel 2, sulfur 3. So those are the first column of writing the formulas. The second column shouldn't be any more difficult. The answer key is posted, so you can try 76 through 100 and check your answers against the answer key that's in Google Classroom. If you need more help than this, you need to watch some of the videos either that I made in previous assignments in Google Classroom in this folder, or that I have posted. I've posted lots of YouTube videos. You can go back and look at the Ed puzzles. So there's lots and lots of explanations and videos that you can take a look at.